one, check two. Check one, check two. Check one, check two. Just checking the mic. We're going to get started here shortly. Happy Sunday, everybody. Happy Sunday. So we're about to get started. Trying to get motivated. As you see the slide, just looking at my phone too. Talk a little bit about advanced cryptography. PKI, public key infrastructure. So that's always big on the security test. Maybe not the advanced features as much. Last week we did basic cryptography. So just stepping through the slides today. Like I said, if anybody has any questions, you can always shoot them in the chat and you can see what's going on, or I don't have a problem redirecting it. But today is advanced cryptography, PKI. pretty dry subject, but the subject we have to get on and get through these slides. It's more of an introduction to cybersecurity class that I usually teach in real life, so I'm just expanding it online. So once again, if you got any comments or questions, we can go through the slides. And so like I said, PKI and advanced cryptography, especially from this thought pattern, if your company has it, you're just using it, right? You're not setting it up or getting it set up. You might have to review it to make sure it's secure. If you go into my playlist, I also have my SIG checks in there to go through each security thing to make sure it's secure. Once again, if you got any questions on anything, as long as it's cybersecurity, as long as it's on IT, just drop it in the box. Like I said, we can pivot to other conversations. I don't have a problem with that. Once again, I'm just checking my stream health real quick. Let's get started. Let's see. Make sure I click on that. Let's see. That's a little line that up. So implementing cryptography. So what is that, right? That's encryption. We're gonna dig down more into it. Everybody's familiar with browser encryption, server encryption. So these are the keys and different strength levels of how you would do that, right? Line it up. Cryptography that has improperly applied can lead to vulnerabilities. It's essential to understand the different options that relate to cryptography. Implement cryptography includes key strength, secret algorithms, block cipher mode of operations, and cryptography service provider. So one of the many big things in cybersecurity, probably one of the most important tenets is cryptography for encryption. Why? Somebody's listening to you or trying to do a man-in-the-middle attack or steal one of your files. If your files is encrypted, so it doesn't lead to vulnerabilities, right? Somebody steal your files, right? They wouldn't be able to read them. Somebody's listening to your conversation, right? They wouldn't be able to read them. So cryptography is at the top with encryption as far as cybersecurity. The cool thing is if you do HIPAA, PCI, or any of those, if somebody steals your actual database files or your file payroll files, if they don't have if you don't believe they have the key, you don't even have to report those files as stolen, right? Because theoretically, without the key, they can read the files, right? So key strength. Cryptographic key, a value that serves as input to an algorithm, transforms plain text and vice versa into descriptions. Three primary characteristics to determine the resilience of the key. To attack is called the key strength. Part of the key is your randomness. Trying to adjust the slide up, but the randomness, length of your key, and crypto period, length of time in which a key is authorized for use. Right. So every 2 or 3 years, you should rotate your keys or generate new keys. Why? If somebody steals those keys or happen to get those keys, if you rotate them every 3 years, right, they will only be good for that longer period. Right. And we'll delve in there. So when you talk about blockchain and crypto, right, behind the scenes is the cryptographic keys are how long, right? Blockchain is using cryptography on that for keys, and those block lengths are right. What crypto coins? So those are different things that builds on top of that blockchain. So if you look at key length of 17,576. Number of attempts to break it is 8,788. Right, so longer the key is, right at the bottom is billion. 208 billion, right? So when I do key length, especially, I worked at, a lot of people know me, I worked at DOD or different organizations. Our key lengths are 2048, right? So you can imagine how long it would take you to break a 2048 length key, right? So the longer the keys, the more attempts you have to break it, right? Now we're going to jump a little, but now when you start talking about what? Quantum computing, multiple nodes, how many nodes you can spin up, right? So now it's easier to come up with 2 billion, 2 trillion, or petabyte of information, right? Because with quantum computers and the speed of what you can spin up nodes is, it makes it a little easier to actually break some of those keys. So what's a secret algorithm? Where the secret algorithm enhances security in the same way as keeping a key or password secret. That's a no. For cryptography to be useful, it needs to be widespread. A military force that uses cryptography must allow many users to know of its existence to use it. So at the top one again, would a secret algorithm enhance security in the same way as keeping a key or password secret? No, right? Because you got to get those keys out to many people and many organizations. Block cipher modes are operational. Block cipher manipulates an entire block of plain text at one time. So now we're talking about the speed of use of that. Plain text is divided into separate blocks of specific links. Each block is encrypted independently. A block cipher mode of operations specify how block ciphers should be used and handled in these blocks. Most of the common ones are electronic code book, cipher block chaining, counters CTR, and glosses counter GCM. So we'll digging more into what those blocks are and how they're calculated and how they get their actually name. So crypto service provider. So allow an application to implement an encryption algorithm for execution. Crypto service provider typically implements cryptography algorithms, generates keys, provide key storage, authenticate users by calling various crypto modules to perform specific attacks. Crypto service providers can be implemented in software, hardware, or both. So when you get some of the bigger keys and some of the most big organizations, they're actually going to use hardware. Why? You're going to use a chip just to handle all your encryption, do your work. It's going to run at exceptional speed, right? So that's what they're going to be generating on that. So that shows you the Microsoft Windows 10 crypto provider. It shows you the service local, cryptographic service, if it's running or not, provides 3 management services. So that's Microsoft Crypto as a service, right? So I have to admit the advanced crypto is pretty dry, but that's one of the boring sections. But We're gonna get through it on a Sunday. Let's make it happen. Like I said, this stuff too is on your test, and two is we use some of these. Now we use this a lot in cybersecurity. So algorithm input. Some cryptographic algorithm require an addition to a key. Another value can or must be input. May be called an algorithm input values. A SALT. A value that can be used to ensure plain text when hashed will not consistently result in the same digest. Most often used with password-based systems. A non is an input value that must be unique within the specified scope. Initialization vector, most widely used algorithm input. So, what's up, Jennifer? I just passed my 601. Congratulations, man. Computer security plus services. You rolling, man. So you making a big move. Congratulations on that, Jupiter. So a SALT, a lot of times they should be a Apache administrator. So the SALT is when you put your password in, we would put additional 5 alpha characters in the back and additional 10 in the front. We want your password to be at least 50 in length, right? So you would put in 14 and we put additional on the front and the back. So now when a hacker will try to log directly into the database or the website, the web server actually put additional characters on. So if somebody was actually doing watching you or trying to steal your keystrokes, they would steal your 14, but they wouldn't know on the back end we were adding additional characters to the front and the back of your password, right? The two is a nonce is the web server would generate a Java key to go along with that transaction. So if somebody try to replay that transaction or steal your password and start replaying and trying to steal credit cards or stuff by replaying that transaction, since we got a nonce, they wouldn't know that 15, 30 character initialization code that we would send along with your transaction, right? So the SALT is we're adding special stuff to the front and back of your password. So we're gonna make it super complex, right? So if somebody's trying to steal your password, typing it, or trying to listen to it, they wouldn't have it right because we put additional characters on the front and back end. Initial vector two is once it spins up, the software is going to initialize some key stuff for you anyway. What's up, Bose? Shout out to Jupiter making things happen. So digital certificates, a common application of cryptography. Using digital certificate involves understanding their purpose, knowing how they are managed, and determining which type of digital certificate is appropriate for the situation. So we're going to go through the digital certificates. Like I said, I usually do them from a web server programming aspect. You take your digital certificate, upload it in Apache. They're going to show it's going to do the HTTPS for the browser. Or you just use those digital certificates, and if you segment stuff in a database, those are the certificates we use would make your the data get saved in the database on that disk. So we're gonna delve into that. Digital signature used to prove a document originated from a valid sender. Weakness of using digital signature: it only shows the private key of the sender that was used to encrypt the digital signature. Imposters could post a public key under a username. All right, so those are the things we're gonna do. We're gonna show how we would take care of that, but those will be issues. Once again, this is advanced cryptography module. It's a little dry, but we're gonna get through it. So this shows you the public key of Bob. Bob creates and sends a real message in Bostock now. Mallory intercepts the message and creates an imposter key. It sends that different message on to Alex. Alex retrieves it with the imposter key. Now, right? So now I know I can steal Alice's information, right? Because she's using my key and I'm the posture key. Right? So that was the man in the middle attack. Right. So those are some of the things we're going to try to protect by using keys, using messages, right? Using digital signatures. So defining a digital signature, trusted third party helps to solve the problem of verifying identity. Verifies the owner and the public key belongs to the owner. Helps prevent man-in-the-middle attack that impersonates the owner of a public key. That's what we were looking at between Bob and Susan in the last graphic. A digital certificate is a technology used to associate a user identity to a public key. This has been a digital sign by a third-party trusted party. And when you look in your browser, once again, we're going to see it when we go further. VeriSign, Komodo, when you pay your money and get your certificates from those commercial vendors, they're the third party that everybody trusts. And we're going to look at that. When you look in your browser, it tells you which third parties users we're going to trust and how we're going to go about it. So managing digital certificates, several entities and technologies are used to manage their digital certificates. The big ones are certificate authority, CAs, and tools for managing certificates. What is the security authority? It's a CA responsible for digital certificate. May also be called a root CA. When you get the root right, that's the main part of the key that can unlock everything, right? So you get the root certificate from the CA. If users wants a digital certificate, after generating a public and private key, a user must complete a request with information such as name, address, email, known as a certificate signing request form, SCR. Using electronic signing, the SCR sends it to the intermediate CA, and the intermediate CA processes the CR and verifies the authenticity of the user. So when I was at DoD, when you got your root CA to put on your ID card, right, you had to take your ID card, your driver's license, and they used to take a thumbprint of you to make sure you were who you say you are. Why would you do that? You know, Department of Defense, super secret. So that's how they validate the authenticity of who you were. So the scenario kind of is if you got a car title application is the same thing as the certificate signing. Signing a car title application is creating an affix public key to the certificate. Visiting a courthouse is like the intermediate certificate authority. Title sent from DA to state DMV is the certificate authority, right? The party responsible for the digital certificate. Right, so that's taking it certificate is like you getting your car and the title from. So they kind of walk you through what that actually is and what it looks like. Intermediate CAs are subordinate entities designed to handle specific CA tasks such as processing certificate requests, verifying the identity of the individual. The person requesting a digital certificate can be authenticated by the email or documents in person. A common method is to ensure the security and integrity of the root CA, keep it in an offline state from the network. An offline CA is only brought online when needed for a specific infrequent task. Right, so you keep it offline, right, to stop the hackers. If they're hacking and it happens to be offline and then use it, right, if it's offline, the hacker or the bad actor or bad adversary wouldn't be able to get that particular information. Right, so that's why you keep it offline. So now we're talking about how you're going to manage your certificates, control your certificates, and keep those in line. Right, a certificate repository, publicly accessible, centralized directory of digital certificates can be used to view certificate status. Can be managed local by setting up a storage area connected to the CA server. Right, this is the big one right here, certificate revocation, a list of digital certificates that has been revoked. The reason a certificate would be revoked certificate is no longer used. The certificate of the deed has changed. Private key has been lost or exposed. The certificate revocational list, CRL, a list of certificates or serial numbers that have been revoked. So you're going to be firing people, releasing people, shutting down servers, and shutting down applications. So if those certificates are good, you want to revoke them, especially if it's a person. If the person has their certificates on their CAT card or on their person, you have to escort them out the door. You got to be able to revoke their access. They could be on 200 or 300 servers. We had admins and programmers and DevOps guys that probably easily on 200 or 300 servers. So if you have to escort one of those guys out, right, you have to take them, get them on a revocation list and yank them off, right? So you got to be able to do that. So that shows you the revocation list. inside your browser where it's like so it's revocation list. So that will show you all the ones that was been revoked. So the certificate management online certification status protocol (OSCP) performs a real-time lookup of the certificate status, calls a request and response. The browser sends a certificate information to the trusted entity known as the responder. The OSCP responders provide an intermediate revocation information on the certificate, and a variation of the OSP with web servers send a query responder servers at regular intervals to receive a assigned time stamp for the response. Like I said, if it was revoked or they expire every 3 years, or there's a couple other things that could be in a different status. So usually once in the morning we looked at those certs, and hopefully right after lunch, so you would have it query like in a 4 hour block to make sure those certificates were good, and people were watching them. So if you looked on there, so this is a typical one. The problem we had is if we worked at DoD, we had 100,000 people and 100,000 certificates. So for us, this particular methodology didn't work because the volume was just so big on that server and how that would actually roll. All right, so you got the web browser connects to the web server. The web server says, okay, is this certificate valid? It goes to the OSP responder. The responder says, yes, it's signed and approved. Approval and it's good. It goes back to the web browser and says, check, that browser's good. Don't block it. Don't put it in red. So type of digital certificates and categories of digital certificate: root, domain, hardware, and software certificates. A lot of times you have software certificates for testing. So if we need to test different users that have different certificates, X509 or just different certificates in that web browser, we will have soft certificates so we can actually use them and test the test for that. If this person is a VP, if this person is a regular user, or what type. So we have different certificates to be able to test each one of those different type of scenarios we would have. When we got our user requirements in real life. So the root of digital certificates process of verifying a digital certificate and the genuine depends upon a certificate chaining. Links several certificates together to establish trust between all certificates. The endpoint of the chain is the user digital certificate itself. The beginning point of the chain is known as the root digital certificate, creates and verified by a CA. Self-signing does not depend on any higher level authority. Between the root digital certificate, the user certificate can be one or more intermediate certificate issued by the intermediate CA. So once again, we create, here's a graph of that. So yeah, usually you chain it because you can have large companies that have headquarters overseas, regional's office, and the headquarters can read the regional office can read the local office certificates, right? So you have, like you see on there, the chaining. So depending on what level you are and what boss you are, you can read people's different emails or files, right? Because they report to you or in your organization. So with the Equifax, we have the root digital certificate, immediate digital certificate, the Geo Trust, two intermediate. Then at the end is we buy .island online is the actual user digital certificate for that chain, right? So each one of those above can read the lower chain. So Jupiter, you gonna go get another job and make all the money? What you gonna do, Jupiter? Once again, congratulations. So yeah, that shows you the chain and how it flows. So this is a certificate chaining for Cengage. That's actually inside your browser. If you go to certificate paths inside your Chrome browser to show you the chain. Digi certificate versus a high-end security versus Cengage, right? So that's see that star at the front. That's called a wild card. So you could put that certificate on any server, your organization. Me as a security guy, I'm not a big fan of wildcard certificate. Why is that? I want to know what each certificate belongs to that specific server in case I have to do forensics on that server. I want to know exactly what specific certificate was on that server. right? With a wildcard, I don't know what server in your organization belongs to that certificate. So I like to match the server to the certificate from a security perspective. Once again, that shows you the details. That shows you the public key. As you say, it's 2048. It tells you when it was done. Obviously, these are old slides to 2018. So after 2018, right, that certificate will be invalid. So that gives you information. The path is the big thing. Most digital certificates are web server digital certificate issued for web server to the client. Web server digital certificate performs two functions and ensures the authenticity of the web server to the client and ensures the authenticity of the cryptographic connection to the web server. Several types of domain digital certificates: domain validation, extended validation, wildcard, and subject alternative name digital certificate. Of course, we'll dig down to each one. So those are kind of certificates that you put on web servers and how they actually get that HTTPS and that encryption. So we're actually about to walk through that. So this is the domain digital certificate. It's telling you how the browser and the server connects and how you get your lock on your browser. So when a web browser spins up, it says client hello to the web server. The web server says server hello. All the algorithms supported in the server digital certificate. 3, it verifies and creates a pre-mastered secret key. If you see the client key is changed back to the web server, and at 4, creates a master secret and session key, sends it back, and then you will have a HTTPS. So a lot of times, if you look, that pre-master secret key, there's been a couple CVEs where people figured out how to hack it and guess or actually steal it and be able to actually read the encryption between the browser and the web server, right? But that's what happens when your browser first starts up, connects it to the web server. It goes through, these are 4 high level things. There's a few more underneath. So domain validation, digital certificate verifies the identity of the entity that controls over the domain. So of course, when you go to google.com, you got the padlock, it's in green, it's good. Everybody knows Google. Google's the big dog. So, right. A lot of times when you go, if they generated itself or it's expired, that will be red. So you would know something was wrong with that certificate. The extended validation type is the type of certificate requiring more extensive verification and legitimacy of the business. So they ask for additional paperwork, more information and stuff on how you get the extended. And 2 is later on in the semester, we're actually going to generate some of those keys and actually put them on a web server so you can actually see that stuff live and in effect. So wildcard digital certificate uses to validate a main domain along with all the subdomains. Basically, that star we looked at, you could put that certificate on any server in your organization, right? Because it's going to be server.google.com. So whatever that server name was, you could put that star on any of those servers for Google, and it would be valid for a Google domain server. Subject alternate name is a digital certificate, also known as a Unified Communication Certificate, primarily used for Microsoft Exchange servers, right? Because those are email servers. There's a little more protection on those too. Hardware and software digital certificate, machine, code signing, and email, right? So those are the 3 main ones, especially email. Now with people attacking email, reading email, so how are you signing your email to make sure nobody is intercepting it on the internet and reading it? So those are, once again, the PKI is kind of dry, so just gonna kind of get through this. But if y'all got any questions, just throw them in the box. Digital certificate format, most widely accepted digital certificate done by Division of ITU, Telecommunications Standard Sector. It adheres to the X.509 standard. All X.509 certificate allows UIT.60, specifies one of 3 basic encodings: basic encoding rule, canonical encoding rule, and distinguished coding rule. So they're going to delve down as how do you encode stuff, especially when you're talking about web service calls and emails. There's communications of encoding behind the scenes of how you unravel that stuff and read it. Public key infrastructure, important management tool to use, digital certificate, asymmetrical cryptography, right? That's a public and private key. Importance of understanding PKI, how it's managed, how key management is performed, and known PKI trust models. So there's different ways to handle keys because when you're in a large organization, you could have thousands of keys you're managing for servers, email server, employees. You can be managing a ton of keys. So what is PKI? There's a need to consistently manage digital certificates. Public key infrastructure, the framework for all entities involved in digital certificates, creates a management action facilitated by PKI. You can create them, store them, distribute them, and revoke them. Right. So those are the four things you do with keys. So a trust model, confidence in or reliance on another person or entity. A trust model refers to the type of trust relationship that can exist between individuals and entities. Direct trust, a type of trust model where one person knows the other. Third party trust is two individuals trust each other because each trusts a third party. Right, so they're going to show examples of each one of those and how those look from a PKI perspective and actually from a security perspective. So the first one is a hierarchical trust model. Assigns a single hierarchy with one master CA called a root. The root assigns all digital certificate authorities with a single key. Can be used in an organization where one CA is responsible for other that organizational digital certificates, right? So the big one in there is one single key, right? The root with one single key. Hierarchical trust model, a single CA private may be compromised, rendering all certificate worthless. Having a single CA who must verify and install the difference may create a significant backlog. So when you actually log in AWS and they give you a root account, they're going to give you a private key, and that's the single private key for your whole AWS infrastructure. So behind the scenes, this is what AWS is doing. Right, so when you talk about it and you refer it in real life, that infrastructure is really what AWS does. When you say, I'm going to create an account in AWS, they give you a root account and they give you a root certificate. And they say if you lose it, you're toast, right? You're responsible for it. Right, so here's a hierarchical trust, one CA, one root key, each one of those digital public key. Here's a distributed trust model. Multiple CAs, signed digital certificate, eliminates limitations of hierarchical trust model. So you can have one CA, intermediate CAs, then you have distributed. So if you're a large organization like Lilly, Boeing, right, you have your corporate headquarters in the United States. Each one of those could be Brazil, European, Antarctica. So you can have CAs for each one of those regions. Right, so those regions were responsible, but if your home office needed to get in one of those regions, right, that home office will be the original root key. A bridge model, one CA acts as a facilitator to interconnect to other CAs. Facilitator CA does not issue digital certificates, instead it acts as a hub between hierarchical and distributed trust models, allows the different models to be linked. So here's the model where you have the CA authority with the hierarchical, then you have the distributed at the bottom. So if you're a worldwide organization or a large organization, right, there's many different ways and how you can set this up. I work for multinational companies. So when you're talking about their CAs and their keys spread out around the globe, right, you have different models like that will work in different ways to set it up. And even in the United States, right, you can have a east, west, south, midwest. So you can use this model even in the United States, right, to break it down and give you a lot more flexibility with your keys and actually how you want to manage them. So managing PKI again, our certificate policies, a published set of rules that govern operation of PKI, provides a recommendation baseline security requirements for the use of operations for the CARA and the PK components. The certificate practice statement, CPS, technical document that distributes in detail how the CA uses and manages certificate. They also cover how to register for a digital certificate and how to issue them and when to revoke them, procedure controls, and key pair management. Like you said, you're going to do this for a large company, so you're going to need to have it set up and how you want to deal with it and handle it. So the certificate lifecycle course creation occurs after you users possibly identified. Suspension may occur when employee leaves on absence. Revocation, certificate is no longer valid. Expiration, the key is no longer being used. All right, so those are the four life cycle things for key: creation, suspension, revocation, and expiration. Right, so those are keys at its length, right? Key management, you got a key storage, key usage, and key handling procedures. So how are you going to handle these keys? So we generate files, generate keys, and move keys. So from key storage, keys usage, and how are you going to handle those keys? Right? So when we need to upgrade a server, how do you move those keys? When you decommission a server, how do you make sure those keys are destroyed, and how do you keep track of that? Since I work for a lot of government entities and federal organizations, a lot of times you got to document that. So when auditors came in, when was the server destroyed? When were the key destroyed? Did you degauss the disk? Did you reuse the disk? So a lot of stuff you have to keep on paperwork to document it, right? So that's the beauty of doing federal and government work. Means of public key storage embedding digital certificate. Means of private key storage stored on a user local system. Software-based storage may expose keys to attackers. Often it's storing keys in a smart card or token. So there's different ways to keep. So when you do key storage and it's on your local system, of course, if you get hacked and the bad guy gets those keys, right, he can read data files, database, whatever you set those keys up to use, right? So you have to super protect them. Multiple pairs of dual keys can be created if more security is needed than a single set of public and private keys. One pair used to encrypt information, public keys backed up in another location. Second pair used for digital signature, the public key in that pair would never be backed up. So, right, so like you said, you got to figure out what you're going to back up, what you're not going to back up, and how are you going to handle it. Once again, behind the scenes, when you set up an AWS account, that's what it's doing for you when you talk about, you get your root, it's actually called root, you get your root and your key pair, how are you going to handle them and manage them? Key escrow. Keys are managed by third parties such as a trusted CA. Private key is split and each half is encrypted. Two half is sent to the third party, which stores each half in a separate location. User can retrieve and combine two halves and use this new copy for a private key for decryption. Keys expire after a set period of time. Renewal existing keys can be renewed. Right, so if you're worried about sending your keys off, you want to make a copy of them. Once again, you can cut them in half, send them to a known third party, and the third party can keep the two halves for you. So if something actually happened to you, you can request those from those entities, put those together, right, and get your infrastructure back. Revocation, keys may be revoked prior to expiration date. Revoked keys may not be reinstated. Recovery, need of recovery keys, employees hospitalized for an extended period of time. Key recovery agent may be used. Group of people may be M of N control. Suspension, suspended for a set period of time and then reinstated. Let me go back there. Destruction, remove all public and private keys and user identification from the CA, right? Which is the root, right? So those are the things you have to do for key management. Once again, revocation, recovery, suspension, and destruction, right? Behind the scenes, most of the time, like I said, AWS takes care of a lot of this for you automatically. If you're doing this for a large organization, right? This is set up behind the scenes, and it works, right? You don't really have to worry about it. The key handling, you got a digital certificate. In group is a whole group. Then inside in group, you have M group. So you can take keys and split them up inside your group. Who can read what? If you got project leaders, right? So that's how you would do it. Let's talk about the transport. How do you keep keys safe? Most common cryptographic transport algorithms: secure, socket layer, TLS, transport layer security, secure shell, hyper transport protocol, secure, SMIME, secure real-time protocol, and IP security. So those are ways that you can set up security to move keys, trap keys, keep stuff safe, keep data safe while you're working. Right? I think I'm gonna touch on a few of these. The SSL, which people really don't use anymore. People use TLS. One of the most common transport layers developed by Netscape. Design with goal was to create an encryption data path between a client and the servers. Uses the AES Cipher SSL version. S30 is current. Right. All SSLs 1, 2, 3 have all been hacked. Right. So TLS SS version 3 served as a basis for TLS v1. Version started 1 is significantly more than secure. Current version is 1.2. So actually 1.3 is out. These slides are old. So we like to use version 1.2 and 1.3. Cipher suite, a name a combination of encryption, authentication messages, authentication mode called the MAC. Algorithms are used with SSL and TLS. Length of keys, a factor to determine the overall security. The key less than 2048 bits is considered weak. 2048 is considered good. So I guess we need to get up to 4096 now. Make sure your key length. But once again, quantum computers is coming, so we still want to get higher level keys we can get. So for 4096 it is. SSH. So when I do a lot of Linux work, I SSH into the box. An encrypted alternative to Telnet protocol used to access remote computers. It's the Linux Unix-based command interface. SSH is a suite with 3 utilities: slogin, SSH, and SCP. The client server ends and connections are authenticated using a digital certificate and password are encrypted. Can be used as a tool to secure network backups. So usually when you're working on a system, especially if you're a Linux guy, 9 times out of 10 you're going to be doing an SSH shell. A common use of TLS and SSL is HTTPS, secure to HTTP at the protocol, a secure version of plain text HTTP over SSL or TLS. Port is usually 443 instead of 80. It starts with, of course, HTTPS. So usually now in Google, a lot of stuff is Google and a lot of websites. They only let you do encrypted stuff. They don't even let you do stuff in port 80. What's up, Wilton? You're good. It's going to be a short day, but welcome. We're just kind of going over advanced cryptography. It's pretty dry. You can catch it on the replay. But yeah, so we just kind of getting to the end of it. So of course, everything you want to do on the web, you want to be on HTTPS. That's it. Like I said, now a lot of times Google and website, they won't let you do anything unless it's over secure. Because I think we're trying to get security from end to end from all companies, especially all government sites, right? But the question is, if the government's in the dark and the government can't read your data, how can they secure the United States, right? So that's kind of the big debate. When we get end to end, we get it secure, right? Law enforcement, FBI, CIA, all those guys are going to be in the dark because they won't be able to sit on your server, watch you, keep an eye on you, right? So when we get to everything is encrypted at a high level, how will a law enforcement, handle being in the dark for your information? Secure real-time transport SRTP, secure extension protecting transmission using real-time transport, provides protection of voice over IP has security such as message authentication and confidentiality for VoIP communication. So VoIP really is just really the phone system. I've actually been doing a lot of security reviews on phone system. Why? It's just packets of your network, right? You got voice packets, you got data packets, all on the same network, all using VLANs, all in, zero trust network, right? All running over Cisco equipment, right? So it's just voice packets compared to data packets, right? So how do you secure them? How do you control them? How do you lock that down, right? Especially if you're the CIA or FBI and you're keeping track of people, right? How do you lock down your phone system, right? IPsec is considered to be a transparent security protocol for applications using software. IPsec provides three-layer protection that corresponds with three IPsec protocol: authentication, confidentiality, and key management. Support two encryption modes: transport and tunnel. Transport encryption only the data portion of each package and leaves the header unencrypted. Tunnel encrypts both the header and the data portion. Right. So usually, if I'm trying to use IPsec between two Windows servers and I don't have security and I struggle to get security, right, I'm gonna throw IPsec on there and I'm gonna do the tunnel. Of course, when you do encryption like that at a high level over 2 bandwidth, it's gonna slow your traffic down, right? Because it's not native to that application. Right? You forcing it on the Windows, but it's a good alternative. Right? So when we talk about mitigation controls, how will we lock down stuff, how will we control stuff, especially on Windows, I always have IPsec in the back of your pocket. If for some reason they're encryption weak or if you're just super worried, I would do TLS over the wire, and I would also put it in a tunnel, right? So they would have to break your tunnel and break your TLS, right? But as long as you're not trying to move a petabyte of data across that line, that's probably what I would do as a form of extra security, security onion, multiple layers of that for as that. So I'm just gonna kind of wrap this up. Once again, advanced cryptography usually is built into the application and equipment you use. So when you use Cisco, you put in ciphers, you're using advanced security, right? Your network admin, I'm sorry, yeah, your network admin, your Cisco admin is going to set up the ciphers, encryption, how you want to do it, how you're going to set up your VLANs, right? That's part of your networking design and your Cisco expert and your Cisco security guy, right? I'm a security analyst, so I understand it, right, at a certain level. So when I ask Cisco guys about certain things, right, we need to work together to make sure that's secure, right, from that. Then once again, from a web server perspective, right, TLS, how you do it, how you look at it, what ciphers are you using, right? If you look back on some of my videos, I use QualSys. It actually check your SSL, your ciphers, your TLS, and it'll tell you. You need to give it a letter grade, A, B, C, or D. A year ago, I did Panera Bread, and I did their website, and it got a real bad grade, and it sucked, and I kind of walked through the issues. I think I just looked at it, and I think they upgraded everything. But there's things to do to make sure, those things are set up. And two is, if you move a ton of data files, so check files, credit card numbers. So you move files across the network to banks and credit cards. If you're doing a smart contract, you're moving them to Lehman Brothers, right? So how are you encrypting those flat files you're moving with that data, right? Advanced encryption in there, right? You're signing it. So I'm signing to make sure it's you, right? And I'm signing it to encryption, and I'm doing a notch to make sure nobody's replaying that transaction to try to get me to overdraw my account, right? All of that is smart encryption at different levels of that service. So that's when you talk about smart encryption, you put all those together. So when you talk about big banks, especially now when you're talking about Bitcoin and smart contracts and just money at a high level and money at velocity, What do I mean? United States sends money to third parties, overseas, Europe, Africa. How are you securing all that? How are you locking it down? What advanced encryption are you using to make sure? And as you see, we begin hacked and ransomware to protect all that data, right? From a cybersecurity perspective and an analyst, how do you go over infrastructures to make sure they're using the right encryption for the right task at the right time, right? So that's kind of me kind of wrapping it up. I just want to go to an hour today. Once again, the advanced cryptography is kind of dry, but I kind of want to add some real world examples at the end of how that worked and how that will roll. I promise you the next couple uh, sessions be much better. Like I said, a little more easier to understand, a little more fundamental. A lot of stuff we can check real world scenarios. Like I said, the infrastructure is set up to handle this for you in the back end with the Cisco guys, the web server guys. So they set all this infrastructure back up using the right ciphers, using the right TLS, setting the IPsec up correctly. All right, so that's all I got for y'all today. I'm just kind of coming in. Happy Sunday. We'll get through the cybersecurity. This kind of introduction to cybersecurity. Get you aware to the terms. Obviously, some of the terms are dry, but get you aware of some of the high level features of understanding on how you set that up and how you review it. So once again, please subscribe. It's me, Professor Black Ops. Have a great weekend. Have a great week. Monday's here. I'm running out of energy.